It is January 14th, 2020. Rational functions with slant asymptotes is what we're talking about today. Today we have very interesting functions, and so it's kind of nice. We're coming sort of full circle today, in that we started this unit by doing long division. So you learned how to do long division. And we're ending it again with long division. So we have a couple of problems today to do for practice, and it's starting with long division. And we're actually going to get slanted asymptotes today. So instead of horizontal asymptotes. Again, calculators are going to be very useful. So if you have your calculator, you'll want to get that out. And here we have number one. This is what we did yesterday. Is it simplified? No. And so what are we going to do? What do we know right off the bat? Okay, yeah, we will factor first, yes. But before I do that, I even want to just look at these leading terms and know that because it's not simplified, I have the option to do long division. Now, if I did long division, I would be asking myself, how many times does x squared go into negative 2x squared? Well, that would just be negative 2 times. And so we can sort of fake that long division on a problem like this. When the x's match, when they're both x squared, and even when they're both just x to the first power, like x over x, we can fake it as well. And just sort of reduce those leading terms. But you are right, we do want to take out the GCF. And so the very first, the numerator here has the greatest common factor. What number would I want to take out? I'm going to take out, that negative 2. If I take out a negative 2 from every single term, I'm going to be left with an x squared. Taking out a negative 2 from a negative 4, that's going to leave a positive 2x. And taking out a negative 2 here leaves a negative 3. How do I know I did that right? I can distribute just to double check. Negative 2 times x squared is negative 2x squared. Negative 2 times positive 2x is negative 4x. Negative 2 times negative 3 is positive 6. So you can always double check by distributing. And then I can double bubble that quadratic right there again. X times x is x squared. What times what gives me negative 3? Positive 3 and negative 1. Good. What information do we get from the numerator? The zeros. Very good. And so since these are the zeros, x, let's see, so we would solve. What is the 0 here? X equals negative 3. And this one, x equals positive 1. All right, so those are the zeros at negative 3 for x, 0 for y. That's why it's called zeros, because the y is 0. And 1 for the x, 0 for the y. What do we learn from the denominator? We can double bubble the denominator, and what does the denominator always tell us? The vertical asymptotes, that's right. So the denominator always gives us the vertical asymptotes. This double bubbles, how does x squared minus 4 double bubble? X plus 2x minus 2. All right. Okay, and those give me the vertical asymptotes. So again, that comes just from solving each bubble. If x plus 2 equals 0, x equals negative 2, and here we get x equals positive 2. So x equals negative 2 and x equals positive 2. These are our asymptotes. All right, we want to set up a little graph here. And hopefully you're starting to get the, I don't know, shall we say, rhythm of these down. So a lot of factoring. It's important to know the vertical asymptotes and the horizontal asymptote. Those are the real key things to know. So here we are at -2 on the x-axis. I'm going to draw my vertical line, and at +2 on the x-axis, my vertical line. And my horizontal asymptote is at y equals -2. So that's -2 on the y-axis. And I draw my horizontal asymptote. And I want to have some x and y values. And all those values we can get from our calculator, which is really nice. But we want to go ahead and make sure that we get enough. And any vertical asymptote, you want to point to the left and a point to the right. So what's to the left of -2? -3. What's to the right of -2? -1, yes. And let's see, we are at x equals 2. What's to the left? 1. And what's to the right? 3, yeah. So we know a couple of these. I know at -3, it should be 0. They told us that. That's what the zeros tell us. Also at 1, it should have an output of 0. We could confirm that with our calculator or just trust our factoring. And some of you noticed that if you made a mistake, then things didn't sort of make sense when you went to use your calculator. So it's actually a really good double check for you. I'm going to plug this into my calculator, making sure that I put parentheses around the numerator and parentheses around the denominator. Folks, you have to be good with your calculator. -2 x squared minus 4x plus 6. Close the parentheses, and then divided by x squared minus 4. So x squared minus 4. And then we can graph or draw. Nice little picture here. Oh, squiggle in the middle. All right, so I'm going to go ahead and just use trace to figure out. And again, it's a good idea to double check things. So when I do trace and type in -3 and hit enter, I do get 0. So I know that that point's totally correct. -3 is 0. And so we can see it right there, and that's where our little L shape's going to be. So I'll just draw my little L shape. I'm going to type in -1 and enter, and I get -2.66. And you can see it on there. It's right there on my little squiggle, so I could graph that. -1, -2.66. That's below my asymptote there. I can plug in 1 and hit enter, and I get 0 again. So 1, 0 is another point. Again, you can see it there on the little squiggle. And then I can just connect my little squiggle through those 2 points really nicely. And then the very last point, I do 3, enter, and I get -4.8. And you can see it again. There it is on our little hyperbola. So 3, -4.8 is about right there. And then I can draw my little hyperbola shape. Okay. So really use those calculators to help you draw a pretty nice looking graph. Okay. And again, all these x values just come from the left and the right of each vertical asymptote. Really easy, nothing hard about it. Use those calculators. This is what we did yesterday. It wraps up a lot of information. And so today, we're actually going to have to use long division. We only have one practice, and hopefully long division should hopefully be okay. So you'll notice here, it says use long division, determine the slant asymptote graph. So use long division to determine the slant asymptote. What's different about these, the numerator and denominator today? It's x squared in the numerator, but x to the first, yeah, just x to the first power in the denominator. I lovingly call this top heavy. It's got a higher power, a higher degree in the numerator. And so that's really like an improper fraction. It's like having 25 ninths. it's heavier on top. It's improper. And because it's an improper fraction, then we can actually do some long division to turn it into a mixed number. How many times is 9 going to 25? 2 times. That gives me 18. We're going to subtract 6, 7. And then this is our remainder. So we write 7 2 and 7 ninths. Okay. So what we have here is actually an improper fraction. It's the exact same idea. And because it's an improper fraction, we are going to do some long division. Where to put it? I'm just going to do it right here. So our divisor is 3x minus 4. So 3x minus 4. And we're dividing into negative 6x squared plus 11x minus 2. And it's that very first division step, that's the difficult one. We're just dividing the leading terms, negative 6x squared divided by 3x. How does that clean itself up? Yep, negative 6 divided by 3 is negative 2, and x squared divided by x is x. So negative 2x. What do we do after that? What's our pattern? Divide, multiply. Yeah, so we are going to multiply. Negative 2x times 3x is negative 6x squared. Negative 2x times negative 4? Positive 8x. Good. What's the next step after we multiply? Subtract. So we're going to subtract everything. Please, please, please make a giant subtraction sign, and don't forget those parentheses. They're really, really important to help us remember to subtract everything. Bless you. Negative 6x squared minus a negative 6x squared is 0. And then we have 11x minus 8x, which is 3x's. And then what's the next step? Bring down. Bring down, and we're going to bring down that negative 2. And then what do? Repeat the process one more time. So we're going to repeat again. And we're dividing leading term by leading term. So how many times does 3x go into 3x? Yeah, so that's going to give us that 1. So positive 1. And we multiply. 1 times 3x is 3x. And 1 times negative 4 is negative 4. So that was multiply. Now we're going to subtract. 3x minus 3x, 0. Negative 2 minus a negative 4. Positive what? 2. Okay, good. That's right. Minus a negative becomes plus, so it's negative 2 plus 4 gives us. And what's 2 going to be called then? The remainder. I'm just going to use arc. And so negative 2x plus 1 is the quotient. And we're just going to write plus the remainder over the divisor. And this is so it's a mixed number, essentially, is what it is, what we just did up here. A mixed number. And, hey, the very cool part, when we do the long division, this quotient is our slant asymptote. So our slant asymptote is y equals negative 2x plus 1. That is the equation of a slanted line. Think slope-intercept form, y equals mx plus b. Mx plus b. And so we're going to graph that slanted line. Where do the vertical asymptotes come from? Where do they come from? Vertical asymptotes always come from the denominator, whatever the denominator is, okay? And so we are going to solve that. 3x minus 4 gets solved equal to 0. How do you solve for x? Add the 4, so 3x equals 4, and then divide by 3. So we get x equals 4/3. That is our vertical asymptote. always comes from the denominator. So these are our two asymptotes that we're going to graph. So I'm going to make a little sketch here. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And let's see, my vertical asymptote is at 4/3. That's a little bit more than 1. So right here is 4/3, 1 1/3, a little bit past 1. Vertical asymptote. Now, negative 2x plus 1 is a slanted line. It's in slope-intercept form. And we're going to start at the B for begin. That's 1 on the y-axis. And then my slope is negative 2. What does that slope of negative 2 mean? We always have to turn it into a fraction, right? Down to right 1. So from our beginning point, we're going to go down to right 1. Down to right 1. To right 1. And so we get this slanted line, and we're going to just sort of morph it into a slanted asymptote. And you can see we still have our graph divided into like 4 sections here. Got this large section, then a skinny pizza pie, pie slice, and then here's a fatso and a skinny one. Okay. All right, again, just like before, we're going to fill half of those sections up with a hyperbola. All right, it's sort of a L shape, or might be a V type shape. But to help us out, we want to go to our calculators. And before I do that, I'm going to do XY chart. Just like before, we want a number to the left and a number to the right of our vertical asymptote. So what's a number to the left of our vertical asymptote? 1 certainly is a number to the left. We can always do more than 1 if we aren't sure what it is going to look like. So we could do 0 as well. It's just in our calculator anyway, so why not? What's a number to the right of our vertical asymptote? 2 and 3 are to the right. I'll just do 2. But you could do 3 if you wanted to. And again, I am going to plug this into my calculator, so we want to make sure that we put parentheses around the numerator and parentheses around our denominator, just so we do it correctly. I use the Casio this time. So I'm going to go to my graphing menu. I'm going to delete this equation, and I'm going to type in parentheses negative 6x squared plus 11x minus 2 divided by 3x minus 4. So I have my equation. I'm going to execute, so it's highlighted. You see how that equal sign gets highlighted? That means it's actually going to graph it. And I'm going to hit draw. Oh, interesting. So now our hyperbola shape, here's our little L shape. Again, it's bordered by our slant asymptote. And here's the other one. Very interesting graphs. Again, I'm going to use trace. Trace and type in some values. So I'm just going to type in 1 and get, delete, and get a value of negative 3. 1, negative 3. And I type in 0, enter, and I get 0.5. 0.5. I'm going to type in 2, enter, I get negative 2. And I'm going to type in 3, and I get 4.6. 4.6. So with some nice values, 1, negative 3 is right here, and 0.5 is right there. What's happening is we're just running right along these two asymptotes, just like that. And so sort of wide hyperbola. We have 2, negative 2, which is about right there, and 3, Negative 4.6. I was like, what? What's something's wrong? Negative 4.6. 1, 2, 3, 4, and a bit. It's about right there. So again, we're just sort of bound by these two asymptotes. So similar shape, just nice and smooth. No sharp corners. That's a really good graph, ladies and gentlemen, okay? So take your time, draw nice pictures. I think you've only got 4 or 5 problems to do. Okay. Do you have questions for me? Okay, so long division today to give us that slanted asymptote. It's going to be a 2-step long division. You're going to have to run through it twice, I think, most times. So you get a line. All right.